pH scale. The pH scale, well, pH stands for power of hydrogen. That's what the P is power, H is hydrogen. So it measures the strength of the hydrogen ion. We use the pH scale to tell us how acidic or basic a substance is. Each pH unit is 10 times more acidic than the next higher pH unit. So this is what we call a log scale. And you've seen log scales before. Earthquakes, for instance, they're a log scale. So if you had an earthquake of 2 versus an earthquake on the Richter scale of 3, it's actually 10 times bigger, 10 times stronger. If you had an earthquake of 2 compared to 4 on the Richter scale, it's 10 times 10, it's 100 times greater. Another thing is when we measure sound. We measure sound in decibels, and every step is actually a step of 10. So pH is the same thing. The following figure shows the pH values for various substances. So if we look at this picture, it's just kind of interesting. So 0, very low numbers, are acidic. Higher numbers, and the pH scale only goes up to 14, tend to be basic, which means something in the middle is neutral. So water, pure water, is 7, it's neutral. And this is where we want to be. When you're swimming in a swimming pool and your eyes really start to burn, it's not necessarily how much chlorine is in there, but the pH might be a little bit off. The pH might actually start going more towards the acidic side, and then you have to add a little bit of a base in there to neutralize it out. So pH scale goes between 0 and 14. The really low numbers are acidic, so something like 1, 2, anything under 7 is considered acidic. Anything above 7 to 14 is considered basic. So if I just look at this little comparison down here, so the smaller the number, the closer we get to 0, the stronger the acid is. So if you had a pH of 6, that would be considered a weak acid. 7 is neutral, maybe 8, 9 is a weak base, something like 13, 14 is a very, very strong base. And again, what we're measuring is we're comparing how much hydrogen ion do we have compared to hydroxide. When you see the hydroxide, we know that means it's a base. When you have the hydrogen out in front of the formula, that's an acid. So when there's more hydrogen ion, it's acidic. When there's more hydroxide ion, we know it's a base. So when we're looking at the pH scale, a solution with a pH of 7 is considered neutral. And this is what's ideal for our everyday lives. So if you're swimming in a swimming pool, you don't want to be swimming in a pool full of acid or something very acidic or very basic. Your skin and your eyes will start to burn. We want to be close to 7. When you drink water, you want it to be close to 7. Rainwater is slightly acidic, but pure water is actually 7. It is neutral. So anything below 7 is considered acidic. So a solution with pH less than 7 is considered acidic. A solution with pH greater than 7 is considered basic. Now, you may say, well, are acids the only bad things? Well, if you have a very, very strong acid like stomach acid or hydrochloric acid, something really, really strong, it can actually burn your skin. It could burn holes in metal. However, if you go to the opposite extreme and get something like drain cleaner, that also can damage your skin. So it's not to say that one's more dangerous than the other. What we want is something in the middle, like water. We want something neutral. So the importance of pH. We know that blood that's too acidic cannot transport and release oxygen. And it's funny that what you eat can actually affect the acidity of your blood. If you have a very acidic diet and you eat very acidic foods, lemons are extremely acidic, it can actually change the pH in your body and affect your health. Soil. Acidic soil causes leaching. So leaching is when it rains and it washes all the nutrients out of your soil. So if you find that your soil is very acidic, your plants aren't going to grow very well either. I compost all my vegetables, but one thing I don't put in the compost are actually lemons, like the lemon peels and such, because lemons are acidic and it could increase the pH of the soil, and I don't want that to happen. So it's a good idea if your plants aren't growing well, it's like test the pH of your soil. Okay, it should be neutral. It should be neutral. Pickling foods. Well, when we pickle foods, we want like a low pH. So something like vinegar. I know my parents always pickle peppers, and people pickle different things, but we put it in vinegar because a low pH preserves the food. Okay, kills any bacteria, anything that would cause the food to go bad. Shampoo that's too basic can actually cause dry scalp. Scalp is naturally slightly acidic. So a lot of commercials say, oh, the shampoo is pH balanced. And what they're meaning is that the product matches the exact pH of whatever body part you're putting on. If it's shampoo, it would be like of your head. Another one's deodorant. You'll hear that in advertisements where it's like it's pH balance, where it matches the pH, like, under your arm. So knowing what the pH is actually very, very important to us in our health.